You know this picture, right? Of course you do. We've all seen it. The famous March of Progress. It shows this nice, clean, straight line from an ape to, well, us. It's simple, it's easy to understand, and it's totally wrong.
Because what if our story isn't a lonely march forward at all? What if, for millions of years, our ancient ancestors were not alone? What if they had neighbors?
And that right there is the key. You gotta forget the straight line. As anthropologist Lucas Stilizane says, our family tree is actually quite bushy. It's this tangled, incredible story with all these dead ends and twists and way more characters than you probably imagined.
Now, to really get why this bushy idea is such a total game changer, we have to look at a huge problem that's been bugging scientists for decades. A giant, gaping hole in our own origin story.
Yeah, I'm talking about a really critical period in our evolution where the fossil evidence just kind of vanishes. It's like a black box, right at the exact moment our own genus, Homo, the branch that leads directly to us, was supposed to be getting started.
So here's what that looks like. We've got amazing fossils of hominins, like Lucy's species, Australopithecus, from around 3 million years ago. And then we've got fossils of later Homo species after the 2 million year mark. But that million-year gap in between, it's been mostly silent. Who was around? What was happening then?
But then, at a research site in Ethiopia called Ledi-Geraru, a team of scientists made a discovery that didn't just fill in a blank. Oh no, it completely rewrote the entire story.
This is what they found. The oldest confirmed evidence of our genus, Homo, ever discovered. It's a fossil jawbone, and it dates back a staggering 2.8 million years. This one find pushed our origins back by almost 500,000 years. I mean, that alone is a massive discovery.
But as incredible as that was, believe it or not, it wasn't the most shocking thing they found in that ancient dirt. Something else was hiding there, something that would completely change how we see our own family tree.
And here it is. This is the bombshell. The team discovered that not only was our direct ancestor Homo living in this exact spot 2.6 million years ago, but so was our distant cousin Australopithecus. They were literally neighbors, living side by side. This was huge because the thinking was that Australopithecus was long gone from this area before Homo ever showed up.
So what does this all mean? It means that simple March of Progress picture is officially dead. It's time to throw out the line and start thinking about a bush.
So his bushy tree idea shows that human evolution was this really dynamic process with lots of different hominin species sharing the planet at the same time. Many of these branches were just evolutionary experiments that, eventually hit a dead end. Only one, ours, actually made it. Think about that. We're like the last little twig on a once very, very bushy tree.
Now, here's where it gets even cooler. This wasn't just some one-off thing. The cast of characters in our ancient family drama actually changed depending on where you were on the continent. It wasn't one big, happy, mixed neighborhood all across Africa.
And this just illustrates that point perfectly. If you were in southern Africa, early Homo was sharing the landscape with a totally different hominin called Paranthropus, this really robust cousin known for its absolutely massive teeth. But if you go up to Ethiopia, where this new discovery was made, no Paranthropus fossils. Instead, Homo was neighbors with Australopithecus. Different places, different neighbors.
So you might be wondering, how can they be so sure? Well, it all comes down to the teeth. Teeth are the toughest part of a skeleton, so they're often the only things that survive for millions of years. And an expert can spot these subtle but really consistent differences in shape that just scream different species. In this case, the teeth told this undeniable story of two separate hominin groups sharing the exact same ancient landscape.
But of course, like all great scientific breakthroughs, this one answers a huge question while at the same time opening up a dozen new ones. The story is definitely not over.
I mean, these are the questions that keep paleoanthropologists up at night now. Did our ancestors just nod to their Australopithecus neighbors as they walked by? Were they competing for food, or did they just totally ignore each other? And you have to wonder, did this competition maybe push our own lineage, Homo, to develop new tricks like tool use just to get an edge? We have the teeth, but we still have no idea what the rest of them looked like. The search is on.
And that leaves us with this one last kind of mind-blowing thought. If we just found this completely unexpected neighbor after all this time, who else is still out there, just waiting in the fossil record to be discovered? Just how much bushier can our family tree possibly get?
So the next time you see that old March of Progress picture, you'll know the real story is so much more crowded, way more complex, and honestly, a lot more interesting. If you enjoyed this deep dive into our ancient family tree, make sure you subscribe for more explainers that kind of rewrite what we think we know. I'd love to hear your thoughts in the comments. How do you picture our ancient ancestors interacting with these other hominins? Let me know what you think. See you next time.